This activity just asks us to wrestle with the concept of a function. What is it that makes a function a special kind of relationship? Right? So what is the answer to that question? How do we know when a relationship is a function?
Plug in 1x and
No, you're halfway through the sentence. So why?
you plug in 1x and you get 1.
Yes. If you plug in a single value of x, you can only get one value of y. Every input has a unique output. And so we're asked to consider that in several different cases. Let's start with this relationship between x and y that's shown on this graph. Is y a function of x?
No.
No. Why not?
For those 2 points that are on the circle there, that's one value of x, but there's 2 values of y.
Yeah. So they've sort of given us a bit of a leg up here because they've labeled this point -3, comma, square root of 7, right? But there's another point on the circle that also has the same x coordinate, right? -3. What's the y coordinate on that point?
-3?
Yeah, it becomes negative square root of 7. That doesn't really matter what that value is. What matters is that it's the same x, but 2 different y's, right? Okay, and as soon as we find even a single x for which that happens, the baby goes out with the bathwater, right? It's not a function. In order to be a function, every x in the domain can only have a unique y. So what do we then conclude about this weird graph? Function?
I was confused with the open.
I think the brilliance of including this as an example is that those open and closed circles throw everybody off. So what did we decide? What was the meaning of the open and closed circles on this graph? Yeah.
The open circle is a jump, and the closed circle is actually a point.
Right. The closed circle represents a point that actually belongs on the graph. The open circles are points that don't belong. It's like the difference between the square bracket in interval notation and the parentheses in interval notation, right? Is this point included in the graph, closed circle, or is it not included in the graph, open circle, right? So let's say I were to ask you for this graph, what is g of 0? When x is 0, what is y? 1, because that's where the closed circle with an x coordinate of 0 lives. What about g of 2?
There's no place for y.
There's no place. There is no point on this graph that has an x coordinate of 2. So g of 2 is undefined. Right? Is this the graph of a function, y a function of x? Why? How can we tell?
Because if you put in 1x, you get 1y.
Yes, there is no x that I can put in to this function that gives me multiple y's. There's some x, like 2, that give me no y's at all, right? Because it's not in the domain of my function. But any x that's in the domain gives me only a single y. So this does represent the graph of a function. By the way, does anyone know what the graphical thing that we're looking for is called? You may have seen it in a previous course. Like, what test am I applying to these graphs to decide if the graphs of functions or not? Yeah, I'm kind of giving it away over here. It's called the vertical line test. Right? A graph depicts y as a function of x if every vertical line that I can draw does what?
Has 1.
Intersects the graph at most once, right? I'm coming back to this g of 2 example again. We can have vertical lines that intersect the graph not at all. That's okay. But any vertical line that does intersect my graph can only intersect it in one spot, right? If y is a function of x. This vertical line over here intersects my graph multiply, right? So this is definitely not the graph of a function, but a graph does represent y as a function of x when it passes the vertical line test. Every vertical line that crosses the graph only crosses it once. So that's the graphical test. Parts B, C, and D, which I'm going to leave for you to talk through in your groups on your own. There you're going to have to think again more about the context of these questions. Is it ever possible for me to have an input that has multiple outputs? And if that answer is yes, not a function. But if that answer is always no, you got a function.